Welcome to this week's edition of Flashback Friday, your opportunity to get some good review by listening to episodes from the past that Jason has handpicked to help you today in the present and propel you into the future. Enjoy.
Welcome to the Holistic Survival Show with Jason Hartman. The economic storm brewing around the world is set to spill into all aspects of our lives. Are you prepared? Where are you going to turn for the critical life skills necessary to survive and prosper? The Holistic Survival Show is your family's insurance for a better life. Jason will teach you to think independently, to understand threats, and how to create the ultimate action plan. Sudden change or worst case scenario, you'll be ready. Welcome to Holistic Survival, your key resource for protecting the people, places, and profits you care about in uncertain times. Ladies and gentlemen, your host, Jason Hartman.
Welcome to the Holistic Survival Show. This is your host, Jason Hartman, where we talk about protecting the people, places, and profits you care about in these uncertain times. We have a great interview for you today, and we will be back with that in less than 60 seconds on the Holistic Survival Show. And by the way, be sure to visit our website at holisticsurvival.com. You can subscribe to our blog, which is totally free, has loads of great information, and there's just a lot of good content for you on the site. So make sure you take advantage of that at holisticsurvival.com. We'll be right back.
Now's your opportunity to get the Financial Freedom Report. The Financial Freedom Report provides financial self-defense in uncertain times, and it's your source for innovative, forward-thinking investment property strategies and advice. Get your newsletter subscription today. You get a digital download and even more. Go to jasonhartman.com to get yours today.
My pleasure to welcome John Wong to the show. He is a professor of biology and cognitive science at Vassar College and the author of Darwin's Devices, What Evolving Robots Can Teach Us About the History of Life and the Future of Technology. Very interesting title for sure. John, welcome. How are you?
Well, thank you very much for having me, Jason, and I'm doing fine.
My pleasure. Tell us a little bit about first your background as a professor and so forth and how the book came about.
Sure. Yeah, I'm really a biologist by training, and so I've always been interested in how animals work kind of from a reverse engineering point of view. How can we use engineering principles to try to understand how animals work as athletes? And then I've also gotten interested in how those athletic animals evolve over time. So I'm very curious about our own human origins packaged into the deep geological history of the group of animals that we belong to called vertebrates. And so I know about, for example, biomechanics is the field of studying how animals work, and then evolutionary biology. And then recently have gotten into cognitive science as a way to explore how it is that animals and machines behave intelligently.
Fascinating. You know, that's interesting when you talk about animals from an athletic perspective. It just made me think of something which probably totally unrelated, but martial arts were developed by watching animals, I hear, especially the feline kingdom there, and you know the way they use balance and energy and so forth. So that's very interesting. But when you talk about robots, I mean, that makes me think of androids in movies and so forth. What are you talking about when you mean robots? Is that what you're talking about?
Well, not really. I mean, that is the classical view of robots, but robots are so much more varied than just humanoid-looking creatures. I mean, we have right now commercially available, and you may have one in your house for all I know, a Roomba, for example, which I like to think of
I do have one. Yeah.
Okay, you know, a giant mint patty or hockey puck or whatever you want to call it. So we have lots of these robots in our lives already, and some of them don't look like animals at all, and very few of them actually, even on the development stages now, look like humans, and then a whole bunch in the middle look like various kinds of animals. You may have heard of cheetah, for example, which recently Boston Dynamics built and then heralded as the fastest running of any robot that has been created so far.
I haven't heard of cheetah. By the way, how fast?
About 20 miles an hour.
Well, that's pretty good for a robot. It hasn't quite caught up with nature, but
that's right. Not as fast as a real cheetah.
Yeah, right. Which I think is like 70 miles an hour or something crazy like that.
Exactly. Yep.
Well, you say teaching us about history of life. I mean, robots seem like they're about the future, not history.
Ooh, that's a great point. Yeah, and what we can do with robots, a special kind of robot called a biorobot, is we can design them to mimic what we think ancient extinct fossils looked like. And the problem, if you're a biologist, is you want to know what happened, as I do, 500 million years ago, but dead fossils tell no tales. So how do we reconstruct what life was like 500 million years ago? Well, we build these lifelike robots that have a quality that's really important, and that's called autonomous behavior. When we build these robots, they have their own brains, they make their own decisions about how they're going to behave in the world. And then we can let them go in an evolutionary trial, if you will, kind of like the Hunger Games, and in our laboratory, but not outside. And we can let them go, and then we just stand back and watch, and then we judge who the winners are, and those winners get to represent their traits through an artificial genome into the next generation. And in that way, we actually simulate evolutionary processes.
Fascinating. So do you design and build robots then?
We do, yeah. I work with teams of engineers and biologists, biochemists, mathematicians, computer scientists. It takes a whole lot of folks to do this kind of work. And, we include things like, there's a field called biomimetric engineering, where we actually look at organisms, animals, sharks in particular, and we try to match up the soft, wet, floppy stuff that's on the inside of animal bodies in an engineering realm. So we build artificial vertebral columns, for example, the backbones that we all have as vertebrates, and they have flexible joints that are wet, and they also have rigid bone-like material as well. And so that's its own branch of engineering that we bring into this world, this field that we call evolutionary biorobotics.
And what size are these robots? I'm just trying to picture them and get the audience to picture them.
Yeah, so I'm really interested in stuff that swims, and that's for a couple of reasons. Number one, I grew up watching Jacques Cousteau and nature programs like that, and I always loved the idea of going underwater. And there's so much we don't know about, for example, the bottom of the ocean. We know less about it than we know about the surface of the moon. So exploration has always been of interest of mine of what's happening underwater. And then life underwater is so foreign to us when we live on land, it's just a way to really travel to another world when you scuba dive or you send your submarines down there. So there's also the fact that the first vertebrates were all fish. And so 500 million years ago, the animals with backbones that evolved these internal skeletons were fish-like. So if you want to understand our own deep evolutionary history, you have to study fish. So that's how I got interested in a kind of critter that we build when we build our robots. So our fish-like robots are relatively small, about a foot long. They have a flexible tail on them. They have, well, I'm going to tell you what it is, our trade secret here. We use Tupperware for the body, and we put a computer.
What a plug for Tupperware.
Exactly. We put a little computer inside the Tupperware, and connected to that computer, we put things like paired eyes. We have a special kind of sense organ that fish have called a lateral line, which allows them to hear, if you will, pressure waves that are in the water, so they can detect other creatures around them using their body as sort of a distant touch type of organ. And so we have sensory organs, and we have a brain that makes sense of the senses, and then that brain makes a decision about what the tail is going to do to move the fish, the robotic fish, around the tank. And so we have sometimes a population of 10 of these at once in a big tank in the laboratory that's about 10 feet wide, and we have a video camera mounted, and we stand back and we watch these individuals in a population interact and compete.
And so those are all robots, though?
Those are all robots.
In
and
the
we
tank.
Can build... Pardon me?
Oh, but do you put them in environments with natural creatures?
No, we don't do that, although, you know what, that's an interesting idea. So maybe I'll take you up on it. You can come visit and we can throw in some natural creatures. No, but the way we get variability that we see, a kind of biodiversity that we see in the wild, is we'll create different kinds of robots. So in one of the experiments that we talk about in Darwin's Devices, we have robots that are built to be prey robots, and robots that are built to be predators who are chasing after the prey.
Yeah, and this is all with autonomous behavior.
Exactly right. And so we know enough about the neurobiology of fish brains that we can actually program these robots to behave like fishes. And what fish do is they cruise around eating most of the time. They're always hungry. And they're doing that until they detect a predator, in which case they kind of hit their own cheetah button, and they go, I got to get out of here. And that involves a very different kind of behavior. It's the behavior, by the way, when you go to the aquarium store and they say, don't tap on the glass. They're trying to get you to not cause the fish to think you're a predator. And because it takes a lot of energy for the fish to do the escape response that it does when that happens. And so we can get that behavior, that complicated behavior of a fish, into one of our robots.
It's always amazed me how robots can think, in quotes, autonomously, because they have to do that with the space program. The speed of light is just not fast enough. Even if you're, at Mars, which isn't far in space terms, I guess, the robots have to think by themselves. If there's a probe running around the surface of Mars and a gully comes up and it might fall in and kill itself, it needs to think, because the signal for light, I think, takes, 16 minutes or something like that? Or I don't know. I can't remember. But a long time, way too long to give it commands with remote control, right?
Oh, that's absolutely right. And so on the Mars rovers, Opportunity and Spirit, which have been operating now for years and very successfully, is they get a general plan for mission control. And then they have to enact that plan, as you say, and they have to avoid the gullies, and they have to figure the way around rocks and so forth. And a lot of that technology that was really developed about a decade ago has been now put into things like robotic cars. And we're hearing talk about...
Which we just got a robotic car. The first one was licensed in Nevada just 2 weeks ago, right?
Excellent. Yep, the Google cars. And these are really intelligent machines, and there's pretty good evidence that they are better drivers than most of us. They don't get distracted. So I'm very happy to welcome into my life a robotic car so I can sit there and text like I'm dying to do while I'm driving.
Right. Or you can go out to dinner and have a couple glasses of wine and still be chauffeured home.
Better yet, absolutely. And what you see the car companies doing, and this happens with all new kinds of revolutionary technologies, is you incrementally introduce these pieces of technology. So, for example, now in the Ford Focus, you can get the parking assist so that a Ford Focus will parallel park for you. And that's been available in the Lexus models.
And BMWs too, yeah.
Yeah, exactly. And so you see attention assist now in these high-level cars and things like that. So it's all part of the plan to get us driving safer.
Just a comment on that. What's amazing about the robotic car thing, one would think that flying an airplane is a more sophisticated thing than driving a car. I mean, I think most people would agree, but oddly enough, and I've taken lots of flying lessons, driving a car is really kind of more complex in so many ways, because on the two-dimensional stage, there are so many obstacles in the air, you can generally just fly along. But so autopilot in airplanes came about long before auto-driving cars.
Yeah, they sure did, and I think you've nailed it. I mean, there's a kind of complexity that happens on the ground that's all the time, right, where we've got objects to avoid, there are very small spaces, there are high speeds relative to the kinds of changes you have to make in direction of your vehicle. And so you're right. I mean, we've got really full autopilots now that can take off, land, and fly in between in the air, and we finally caught up with the cars.
Yeah, it seems kind of counterintuitive in a way. So you design your robots to behave, and you talked about the predator robots and so forth. Is that what you were talking about when you said that, the way they behave, like their instinctual program?
Well, that's absolutely right. You can think of it as just like an autopilot, where the robot is making its own decisions. And just to give you another example of something that there's a lot of talk about recently is the drones that are being used most recently in Pakistan, Afghanistan, and Yemen. These drones are, in a sense, partly autonomous. They make decisions on the flying level, like you just mentioned, about controlling for wind shear and things like that. But then there's a human in the control loop who's sitting, I believe, in Nevada.
In Nevada, yeah.
Yeah, and that human is making a decision about the sensory readings. Okay, is that the target we're after? Do I pull the trigger now, or do we wait? That sort of thing. And what's going to happen fairly quickly here is many of those decision-making processes will continue to be made autonomous by designers. And decision-making process is about what am I actually detecting if I'm a robot in the air, or a robot on the ground for that matter. And so there is the technological evolution is going to be things like on the battlefield, where we have robots that have software that allows them to learn as conditions change. And then one of the things I predict in the book, based on what we know about being able to put evolution into how robots work is that if you're a smart military commander, you're going to want robots that can actually evolve their hardware on the battlefield as well to be adaptable.
So they're actually growing in a sense.
Well, there's a difference between growing and evolving. And growing is definitely part of learning. So that's something that an individual can change. But the bummer for us...
But you said hardware. I mean, what do you...
Yeah.
Tell
but
me
it's
about
hard.
that.
Yeah, so here's how evolution works. You need a group of individuals that all vary a little bit, and the traits in which they vary have some kind of genetic code. So let's go to underwater battlefield, let's say, for a second. And let's say we have a bunch of ray-like underwater vehicles that all differ a little bit in the shapes of their wings. And what we find is that there's some conditions, maybe near shore where it gets very wavy, where having short wings is actually better because you can be more maneuverable. So in that group of animals we see in that particular environment, the short-winged rays are better. And so maybe what we do is we say, okay, we're not going to allow the next generation of these robots to be long-winged because we're now fighting in this mine clearance zone and in the wave zone. So the next generation, so we allow just the short-winged guys to produce new generation. We do that on the computer. And then the next set of hardware is all shorter-winged critters. And that's very analogous to what we see in life, which is the change in a population from generation to generation. And only a certain number of individuals in the population are parents, and the offspring generation looks more like the parents than it does like the population at whole.
But robots don't have babies.
No, not yet, but people are working on it, and not in any kind of gross robot sex way. That's not what I mean.
No, but maybe it's a 3D printing kind of way, right?
Well, there you go, Jason. It's exactly right. I mean, there's 3D printers. There are robots that can self-assemble. There are robots that can reconfigure their bodies.
This just sounds like Terminator 2.
Well, it does, and we don't have the liquid metal kinds of processes yet, but in many ways, Hollywood sort of leads us in directions that are already present. Now, I don't think Hollywood is accurate in terms of, Skynet or Cylons or anything like that taking over and developing self-awareness and consciousness, but a lot on the sort of building bodies side does look like it's going to be very feasible.
Amazing. That's incredible. Do you want to explain how a robot would self-assemble or build its own body? I mean,
well, yeah, this gets to your point about growing, right? So if you imagine, one of the amazing things that organisms do, that life forms do, that engineered things don't do, is they essentially construct themselves. And so there is one robot out there that uses, it has some instructions, and that's very lifelike. Those instructions are called your DNA, right? Your genome, and in the genome, what does it tell you? It tells you, well, here are all the proteins you have in your toolbox. And then there are physical rules that guide the way those proteins are assembled. Now, for a robot then, a robot may start out with the equivalent of DNA in a box and a very kind of simple, let's say, a spray nozzle that has some material. And one of the robots I've seen that self-assembles takes 4 little piles of the kind of spray foam that you might use as insulation that sort of instantly hardens. I don't know what the trade name of it is. And it squirts 4 little feet for itself. And it kind of self-assembles. The little box that it starts with now has 4 feet to it. It's got to have some motors too, and you have to figure out how to get those motors in there. But that's then the kind of process. It's like going to gather materials that are around, use energy initially that it's got on board, and this would be the equivalent of having energy in an egg, right? That's the great thing about chicken eggs. They're full of great fat for the chick to use to construct itself. So those are the kind of basic principles that you think about when you have these self-assembling robots.
Really a totally different kind of thinking. I read about that years ago. I was reading some article somewhere, or maybe a book, that talked about space exploration. And it talked about sending a small probe to a distant planet and having it replicate itself and basically colonize the planet with machines.
Right.
I mean, how amazing. That is just totally amazing. Maybe with nanotechnology and, I don't know, a blend of nanotechnology and 3D printing. How does that work?
Well, I think that you're talking about stuff that is totally feasible from what we know now from the robotics end of things. And so we have all these processes that occur in the natural world that we now understand well enough, right, that we can begin to put them into our engineering designs. And one of the things I love, I'm not an engineer, but one of the things I love about working with engineers is they're very practical people, and they have what I call in the book, Darwin's Devices, sort of the secret code of engineers is that if you can build it and it works, then you understand it. So engineers are all about doing practical stuff and showing proof of concept. And so with that in mind, when we build these physically embodied autonomous robots, we're showing proof of concept that we can have intelligence that is built into our machines. The moment you have that kind of intelligence, you say, aha, now we know know something about animal behavior, right? This ability to fend for yourself in the world. Now we can do things like the growth, the development that we just talked about, and like we talk about in the book, we can also do the evolution because we know enough about that process. As soon as you understand all that, and you can harvest energy from your world, and you have materials that you can use, then you can really create exactly the kind of scenario that you're talking about, which is we can send our robots into other universes, or not universes, solar systems potentially, and planets, to do the kind of colonization and reporting back to us that we can't do ourselves.
That's just incredible. I mean, basically they could create the whole world, create the infrastructure, and then we just show up to enjoy it. It's kind of like going on vacation at a beautiful resort. It's
well,
amazing. They could even change the atmosphere. They could produce oxygen, and that's incredible, really, to think of. The implications are amazing.
Yeah, this is not anything we're going to be doing in the next 10 years, right?
No,
but the principles are known.
Yeah, incredible. Well, you talk about all of the time, the people, and the money it takes to evolve, and that's such an interesting way to look at it, evolve robots. Is it worth the expense to answer these questions about the origins of fish? What direct implications does that have to life today, if any? Maybe not yet.
Well, I think for humans, we do crazy stuff like art, music, and this stuff that we call exploration. I mean, there's this natural curiosity drive that we have that has cost us billions and trillions of dollars over the years, from our space program to Isabella funding Columbus to come find the new world. So there really is this thing that humans do called exploration that has a direct payoff, as we were talking about with a space program, or as I was mentioning earlier with underwater exploration with the kind of aquatic robots that we build. Now, if you want to go practical, though, and say, well, that's nice when you have the money, and we don't have the money now. So why is the government funding this in so many ways, from National Science Foundation to DARPA to the Office of Naval Research, Air Force Research, and so forth? And that's because we look at robots as doing dull, dangerous, and dirty jobs that we humans don't want to do, right? And that can be everything from search and rescue, where we can build snake-like robots that can go into little nooks and crannies and find out where people are if they've been covered up by rubble. It includes things like the Deepwater Horizon disaster, where we can have a remote presence in deep water and actually operate in that remote presence to do stuff that you can't do if you're actually a human that's there. So there really are a whole slew of these practical applications for bio-inspired robotics.
Certainly the bomb squads, all kinds of stuff.
Exactly right. No, it's a growth industry. The robotics right now, which has traditionally been thought of as, the welding arm that's in the Ford plant, for example, which has been around for 30 years, it's really undergone a rapid change as we've been able to take robots, give them autonomy, and give them mobility, different ways to get around. Now you can have robots doing a whole range of things, including sweeping your floors.
Mm-hmm. Yeah. It's I bought one of those Roombas for my mother a few years ago, and she just gets such a kick out of that thing. I mean, she loves that. It's just she just thinks it's great.
Well, and that's an example of doing a dull job for humans.
Yeah, right.
Who wants to sweep the floors? Well, not many of us, right? I'm waiting for the dishwashing robot, and I can tell you what, people are working on dishwashing robots.
Well, don't we have that? I mean, it's a dishwasher.
Well, yeah, but but going from the table, I guess, to the dishwasher.
Right,
People want that one.
Sure. I remember when I think it was Sony came out with that robot dog several years ago. And, supposedly that was a pretty big leap in technology where it would learn tricks and it would sort of act like a dog. I looked for one of those actually online a while back, and I guess they've kind of gone extinct.
That's right. Those are the Aibos, they were called. And yeah, people really loved their Aibo robotic dogs. Because you're right, they would have sort of personalities, and they would get a little angry if you didn't pay attention to them and things like that. So yeah, that's a really good kind of example where we use our toys, our kind of entertainment robotics, to get used to the idea of having robots that are autonomous in our lives. And we saw the same thing with video games way back starting in the 70s, right, with the Atari 400 or whatever it was, and Pong, kind of getting us used to the idea of having computers in our lives. And look at us now. I mean, I've got a computer in my pocket, right?
Yeah, it's incredible, and all that processing power in your pocket on your smartphone is what you're referring to, I'm sure, is more than that of NASA at the time we landed on the moon, I hear. It's
Exactly.
Incredible. Talk about the fusion of biology with machines, if you would, and is this what's called a biorobot? It's actually, I don't know how to say it, but genetic material, skin, flesh, organs combined with machine to create maybe the ultimate robot of the future. I don't know.
Well, one of the things that is not happening right now is, we're not really building kind of living machines. So that's a kind of Hollywood scenario that nobody is close to right now. In the tissue engineering world, which is a biomedical world, there is a company in Massachusetts called Organogenesis, and they have the first FDA-licensed living artificial product, and it's a skin replacement. And I've seen this material. I've held it. It's beautiful, and it's great for burns, for example, or if you happen to get into a motorcycle accident and you lose your skin that way, it can be replaced. And it's got living cells in it. It's just amazing that have been grown up not from an animal but from a cell tissue line. And so that kind of work is being done. And what we see happening now in robots is people are starting to talk about growing robots. Right? So you're not far off, actually, when I say that Hollywood is crazy, but Jason, you're not crazy, right? There is then this idea of how do we combine the best parts of animals, which include the ability to heal, by the way, if you have a break. I mean, how many of us wouldn't love when we get a flat tire for the car to go, hey, I got a flat tire, I'm going to fix that flat tire myself while we're still driving. Or maybe we'll limp along while I'm fixing the flat tire. And that's what animals do. They limp along, they, pull a tendon or something like that. Unless they're really hurt, they find a way to slow down, take care of themselves, and in a week or two, they've healed themselves. And so those initial lifelike processes we would love to have in our machines. Now, there are some things that animals don't do very well compared to machines, so you don't want everything that animals do. Animals tend to take a lot of energy in and only give us a little bit of energy out. So they're not very energy efficient. And they'll only take some kinds of things, the yummy stuff we call food. And so actually engineers have circumnavigated that problem by coming up with solar panels, which is a way, really stealing the idea from plants and using the photovoltaic energy to directly supply current to machines. So that's a kind of thing. There's stuff to be used from engineering, there's stuff to be used from biology, and then you try to put it together, and that's where it gets tricky because, as I mentioned before, biological stuff tends to be wet. It doesn't like to be pulled on very hard. It tends to rip easily, and so there are some real engineering challenges the moment you try to put this stuff together into a working, intelligent machine.
Yeah, very, very interesting points. Talk a little bit, expand on that idea of energy efficiency for a moment. So you say animals aren't very energy efficient, and I assume you're including humans in there too. So what you're saying is that when scientists, and I don't know how you would do this equation, but you guys do, you look at the food and the liquids that we intake versus charging a battery in a device. And somehow you figure out how much energy is used in all of that. I don't know if you turn it into an equation of electricity and how many watts it takes to run us versus your computer. But Well, give us some comparison or insight into that, if you would.
Well, sure. My focus is on movement, so I know things like muscle systems versus motors best. So let me focus on that, and that's a case where physiologists, as a kind of biologist studying function, have been interested in energy metabolism and energy efficiency for decades now. And so, people put all kinds of animals, fish and camels and elephants and things like that into a special kind of chamber where you can measure the oxygen consumption rate of an animal. And you may have seen this with Olympic athletes who wear these masks while they're testing out how efficient they are, actually. And so oxygen consumption is related to the rate at which inside your body you're doing this wonderful chemical equation or chemical function that's really equivalent to a controlled burn, and that's called oxidative metabolism. So you're using oxygen, just like a fire does, to convert chemically one form of energy into another, and you liberate that energy at the cellular level. So we can track all that energy use in animals when they're doing something like running. And what we find out is that for the mechanical power that you get out as a human running, meaning how quickly can you move your carcass, your living carcass, how quickly can you move your body across a substrate like the ground, or if you're swimming through a pool. And we can measure based on that external motion how much mechanical power it's taking. And then we can take a look at the metabolic power. And what we find out is that humans, for the amount of food that they're taking in,
and I assume there are three ingredients, though. There's food, liquid, and air, right?
Yep, exactly
those are
right.
all the things we consume. But machines consume air, too.
Well, they do. And so the punchline here on humans is we're about 25% efficient. We lose 75% of the energy we take in, to just the waste processes of converting all that energy.
And what are machines? Are machines 100% efficient? No.
No, they're not. Nothing is 100% efficient. And that gets back to the old, I sort of bum my science students out when I bring up the second law of thermodynamics, which is this law that says that everything over time will tend towards chaos, meaning it becomes less and less organized. And that's because heat can't be reorganized into a more organized form. And so the second law sort of dictates that eventually the universe will just be this soup of disorganized energy. And so what's really cool, so that's called entropy. And so animals are really cool and plants are really cool because they're dis-entropy machines. They actually organize the world locally. I'm getting off track here. Let me get back to
machines. Do machines have entropy, though?
Well, they do. And so we see, and this is back to our problem of what we're going to do on space missions, for example. Things break down. That's part of the process of entropy over time.
But humans can fix themselves to a certain point. I mean, at a certain point we die and we don't fix ourselves, right?
Right, but all that fixing always takes energy. Okay, so now you asked, how efficient are machines? If you look at something like the propeller of a submarine that is pushing a submarine along, that can be tuned just right to achieve something like 97% efficiency, which is much better than the 25% efficiency of a human running along on the ground.
Let me take a brief pause. We'll be back in just a minute.
What's great about the shows you'll find on jasonhartman.com is that if you want to learn about investing in and managing income properties for college students, there's a show for that. If you want to learn how to get noticed online and in social media, there's a show for that. If you want to know how to save on life's largest expense, there's a show for that. And if you'd like to know about America's crime of the century, there's even a show for that. Yep, there's a show for just about anything. Only from jasonhartman.com. Or type in Jason Hartman in the iTunes store.
Okay, so you know what? I'm going to play devil's advocate with you on this energy thing. I don't think it's a fair comparison. Here's why, okay? Here's why. Because if you take a machine like a car or a robot on wheels of sorts, and it's not that the machine, it's that it has the physiology of the wheel, which is just an efficient way to distribute the energy versus legs. Legs are very inefficient, but hey, those legs can do a lot of things a wheel can't do, like climb a mountain. So it doesn't seem like it's the the machine itself, like the motor of the car or the engine of the robot or the freight train, it's the way it uses the energy through legs or wheels. Is that
right way
to
you
look at
definitely
it?
got your finger on something here. So, I mean, you say the comparison is unfair. Well, you asked for the comparison.
Yeah,
so,
right.
I mean,
No,
but look, you've also said, and I totally agree with you here, that animals do something quite different than machines do, which is animals are incredibly versatile performers. Right? Even humans, which aren't the greatest athletes compared to just about any other kind of legged animal out there, are really incredible. You know, right now, if we had to, right, we could probably get up and walk for 10 hours without stopping if we were really motivated. And we could use the little bit of fat that we have on our bodies, or a lot of fat if we have a lot of fat, which isn't much compared to a tank of gas energy-wise, and we could be very efficient in terms of how we're utilizing that stored energy. Okay, and this is where I think people tend to get tied up in knots about efficiency. It's really about performance. That's what matters. What can different kinds of animals or robots do? Energy is important, but that's secondary to sometimes your versatility. And let me give you an example of where inefficiency is actually really important. Anytime you want to stop, you want to be 100% efficient because you want to be able to shed energy, the energy of your motion, into the environment. That's what braking is all about. So to get lost, as engineers tend to do in this idea of optimizing efficiency, is to miss the multifunctionality that animals have.
Right. And that versatility is really a form of energy dividend, I'd say.
Well, that's an interesting way of putting it. Yeah, or maybe, on an evolutionary point of view, it is the fact that we don't discard our old bodies as our species are evolving. We kind of carry our evolutionary history with us, which is why, for example, if I can say, gee, you're interested in human evolution, well, we got to study fish, it's because we're partly fish when you look at our skeleton.
Fascinating stuff. Well, any thoughts about movies, Hollywood, and their portrayal of this stuff? Because that's everybody's perception. That's what a robot is. Is it C-3PO, R2-D2, or Terminator? What is a robot? Just any more comments on Cylons and things like that?
Well, it's all great entertainment, right? And I think that Hollywood has gotten right the fact that we really are exploring animal-like forms of having our machines move around. And, in some ways, humans are incredibly uncreative, right? Every alien you see practically looks like a human. And then when something is like a jellyfish, it's like, oh my God, that's too strange. People aren't going to relate to the jellyfish monster or whatever. And so, some of that is very natural to use nature for design, both design of our engineering and design of our ideas and our stories. And then it's interesting to me in the same way how uncreative we are when we write stories about robots. They tend to be about the robots taking over. And this actually goes back to Čapek, who was a Czech writer who wrote he actually popularized the term robot, which is from the Czech robota, meaning replacement worker. He wrote a screenplay, it was before screenplay, a stage play called Rossum's Universal Robots back in 1911. And in it, of course, the robots overthrew their masters. And so people just keep replaying in scripts this overthrow theme. And really, you can trace it back to our worries about any technology that we develop. We are scared that it is going to run amok. So I think that's really not a very interesting thing that Hollywood perpetuates now. Is it true? Again, it's not true in terms of these machines gaining consciousness. Is it true that machines give us new ways to kill each other and to surveil each other and things like that? Absolutely. So it still boils down to how humans use these machines that we build.
Well, that's an interesting point, and I wanted to ask you to kind of close with that idea. I remember an old Star Trek episode where there was a war going on one planet, and the war was basically just being fought completely by proxy with robots. And it makes you wonder why we have wars at all. I mean, maybe the leaders of each nation should just arm wrestle or something. At some point, the whole proxy thing of use of robots in military. And by the way, I just got a comment because you've mentioned a few times the automated aircraft and the drone planes and so forth. I just hate the idea of how Obama approved the use of drone planes in U.S. airspace. That just really seems like a scary, scary slippery slope. And then last week I heard about how these drone planes are now being equipped with rubber bullets and things to use to control crowds. And, I don't know. I don't want drone planes spying on me. I don't want that just seems like a very big civil rights concern. It's using the military on U.S. soil, and that's unconstitutional. But
and Peter Singer, who's at the Brookings Institute, is very alarmed about the subversion of democracy that drones and robotic proxies allow. And that's because, it's not in the Constitution exactly, when we use this kind of remote force. And it's justified in terms of subverting War Powers Act and so forth that, hey, our soldiers are not directly involved, and therefore this is not a military-type engagement. For example, when we send CIA drones into Yemen to take out a U.S. citizen, whether or not that guy was a bad guy or not, it was a hit on a U.S. citizen, a very, open and public hit. And so all these things are not being discussed by our government, and that's the problem. I mean, these are things we have to grapple with, and the fact that they're just swept under the carpet means that it is ripe for exploitation without the involvement of the citizens.
It sure is. You are very right about that, and it is very, very scary. There was an interesting Supreme Court case about that a couple of months ago, and it wasn't a robot per se, as you would probably define a robot, but it was an example of technology, and the case basically came down to some cops without a warrant put a GPS tracking device on the bumper of some suspected drug dealer's car. And they found out where he went and so forth and all this kind of stuff, and it led to the arrest. And the case basically came down to, can the cops do that without a warrant? Is that surveillance or search and seizure? Don't you have to get a warrant for that kind of thing? And as I recall, the Supreme Court ruled really in favor of more civil rights, which means you have to have a warrant. But what was interesting about the case is that they said, well, one of the arguments was, well, if the police force had enough staff, they could have just followed the guy. The problem was, all they were doing is using technology as a proxy for being understaffed. It would have been no problem to do exactly what the GPS tracking device did with humans. It's just, and you don't need a warrant for humans to follow the guy.
That's right.
So these are interesting debates, but the problem is government has such a technological advantage over citizens that I think that's where the fight becomes unfair. Your thoughts?
Yeah, well, and that's right. And one of the things that we haven't been hearing about in the press, and I keep waiting for it, is when are we going to find the citizen hackers, right, who are tired of this happening? Let's transport ourselves into, for example, a military zone not on our soil where people may have been hit by U.S. drones or Israeli drones or Italian drones. There's over 50 countries with, by the way, robotics weapons programs, so it could be any number of places. And so, how are you going to defend yourself against those drones? Now, it turns out that you can talk about jamming. You can potentially build your own kind of aerial vehicles fairly cheaply and get them up in the air as well.
Oh.
And it's
Yeah.
Pardon me? You don't think so?
Not a fair fight, but go ahead.
Well,
sure.
no, it's not. But look, this gets to the point of anytime you have adaptive behavior in humans, you can at least stalemate what appears to be on paper a superior force. And we have lots of cases of that, right? Afghanistan and Iraq that show that if you're creative, and I'm not advocating, IEDs or anything like that, but, you can improvise and you can get off track and stalemate a superior force on paper. And so I think we're going to be seeing then these citizen soldiers in whatever country, and whether we like them or not, and whether we're fighting against them, we're going to start to see the same kind of improvisation that we've seen with explosive devices with robotic devices.
Yeah, very interesting stuff. Well, just your comment on what was the original part of that last question, which was the concept of the proxy war, and anything more on robots in the military, and then we'll let you go.
Well, one of the things I think that is happening is there's some really great parts of robots in the military, and that is the sort of assistive, non-combative robots. And this is where somebody like Boston Dynamics and building their cheetahs, or their big dogs as they're called, to carry the 100-pound packs for our soldiers, that's going to be a really useful thing for the men and women who serve this country in the military. And so I think that we're going to see a lot of benefits from robotic technologies in the military. So I don't mean to say that drones are nothing but trouble, because they're not, right? There's a good side to that as well. In robots, there's also a good side. And again, it boils down to how we choose to use the technology that we're developing when we build our intelligent machines.
Sure does. Well, John Wong, very, very interesting discussion today. Tell people where they can get the book, and I believe you have a blog. Maybe you can give that out as well.
Yeah, if you just Google Darwin's Devices, you'll find the blog up there at third or fourth on the list, and you can buy the book at your favorite bookseller.
Fantastic. John Wong, thank you so much for joining us today.
Well, Jason, thank you very much for having me. It's been great.
Thank you for joining us today for the Holistic Survival Show, protecting the people, places, and profits you care about in uncertain times. Be sure to listen to our Creating Wealth show, which focuses on exploiting the financial and wealth creation opportunities in today's economy. Learn more at www.jasonhartman.com or search Jason Hartman on iTunes. This show is produced by the Hartman Media Company, offering very general guidelines and information. Opinions of guests are their own, and none of the content should be considered individual advice. If you require personalized advice, please consult an appropriate professional. Information deemed reliable, but not guaranteed.